The National Electrical Code, or NEC, provides guidelines for the installation and protection of electrical systems, including those involving uninterruptible power supplies, known as UPS, and automatic transfer switches, known as ATS. The specific question of whether overcurrent protection, known as OCP, can be placed at the input of the ATS when feeding a UPS is addressed within the NEC. The NEC permits the placement of the overcurrent protection device at the ATS input. This allowance is specifically outlined in NEC section 705.15b3. This section addresses the protection of sources and equipment. It indicates that the overcurrent protection device can be located either upstream or downstream of the disconnecting means for the UPS. This provides flexibility in the design and installation of the system. To understand the implications of this allowance, it's important to consider the purpose of overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect electrical equipment and wiring from excessive current. This excessive current can result from overloads, short circuits, or ground faults. By interrupting the flow of current when it exceeds a predetermined level, these devices prevent damage to equipment and reduce the risk of fire or electrical shock. In the context of a UPS system with an ATS, the overcurrent protection device serves to protect the UPS, the ATS, and the associated wiring from overcurrent conditions originating from either the primary power source or the UPS itself. Placing the overcurrent protection device at the ATS input offers several advantages. Firstly, it provides a single point of protection for the entire system. This simplifies the coordination of overcurrent protection devices and ensures that the entire system is protected against overcurrent conditions. Secondly, it allows for easy access to the overcurrent protection device for maintenance and testing. The ATS is typically located in a readily accessible location, making it convenient to inspect and test the overcurrent protection device. Thirdly, it can reduce the overall cost of the installation. By using a single overcurrent protection device for the entire system, the cost of additional overcurrent protection devices can be avoided. However, there are also some considerations to keep in mind when placing the overcurrent protection device at the ATS input. Firstly, it is important to ensure that the overcurrent protection device is properly sized for the load. The overcurrent protection device must be able to carry the normal operating current of the UPS and the connected load, but it must also be able to trip quickly enough to protect the equipment from overcurrent conditions. Secondly, it is important to coordinate the overcurrent protection device with other overcurrent protection devices in the system. The overcurrent protection devices must be coordinated to ensure that the overcurrent protection device closest to the fault trips first, minimizing the extent of the outage. Thirdly, it is important to consider the impact of the overcurrent protection device on the operation of the UPS. The overcurrent protection device must not trip unnecessarily, as this could interrupt the power supply to the connected load. The NEC provides specific requirements for the sizing and coordination of overcurrent protection devices. These requirements are intended to ensure that the overcurrent protection devices provide adequate protection without causing nuisance tripping. In addition to the general requirements for overcurrent protection, the NEC also provides specific requirements for overcurrent protection of UPS systems. These requirements are intended to address the unique characteristics of UPS systems, such as the presence of batteries and inverters. When installing a UPS system with an ATS, it is important to carefully consider the NEC requirements for overcurrent protection. By following these requirements, you can ensure that the system is properly protected against overcurrent conditions and that it operates safely and reliably. In summary, the NEC permits the placement of the overcurrent protection device at the ATS input when feeding a UPS. This allowance is specifically outlined in NEC section 705.15b3. When placing the overcurrent protection device at the ATS input, it is important to ensure that the overcurrent protection device is properly sized for the load, that it is coordinated with other overcurrent protection devices in the system, and that it does not trip unnecessarily. By following the NEC requirements for overcurrent protection, you can ensure that the UPS system is properly protected against overcurrent conditions and that it operates safely and reliably. Additional details to consider include the specific type of overcurrent protection device being used, such as a circuit breaker or a fuse. Circuit breakers offer the advantage of being resettable, while fuses provide a one-time protection and must be replaced after an overcurrent event. The selection of the appropriate type of overcurrent protection device should be based on the specific application and the requirements of the equipment being protected. Furthermore, the interrupting rating of the overcurrent protection device must be sufficient to handle the available fault current at the installation location. The available fault current is the maximum current that could flow during a short circuit condition. The interrupting rating of the overcurrent protection device must be greater than the available fault current to prevent the device from failing during a fault. Another important consideration is the voltage rating of the overcurrent protection device. The voltage rating of the overcurrent protection device must be equal to or greater than the voltage of the circuit being protected. Using an overcurrent protection device with an inadequate voltage rating could result in the device failing during an overcurrent event. In addition to the overcurrent protection device, the disconnecting means for the UPS must also be properly sized and installed. The disconnecting means is a device that can be used to disconnect the UPS from the power source. The disconnecting means must be rated for the voltage and current of the circuit being disconnected. It must also be readily accessible and clearly labeled. The NEC provides specific requirements for the installation of disconnecting means. These requirements are intended to ensure that the disconnecting means can be safely and effectively used to disconnect the UPS from the power source. The proper installation of a UPS system with an ATS requires a thorough understanding of the NEC requirements for overcurrent protection and disconnecting means. It is important to consult with a qualified electrical contractor to ensure that the system is installed in accordance with the NEC and other applicable codes and standards. A qualified electrical contractor can assess the specific requirements of the installation, select the appropriate overcurrent protection devices and disconnecting means, and ensure that the system is installed safely and reliably. Furthermore, regular maintenance and testing of the UPS system and its overcurrent protection devices are essential to ensure continued reliable operation. Overcurrent protection devices should be periodically inspected and tested to verify that they are functioning properly. Any damaged or malfunctioning overcurrent protection devices should be replaced immediately. UPS systems should also be regularly tested to ensure that they are able to provide backup power in the event of a power outage. The testing should include verifying the battery capacity, the inverter operation, and the transfer switching functionality. In addition to the NEC, other codes and standards may also apply to the installation of UPS systems with ATS. These codes and standards may include local building codes, fire codes, and insurance requirements. It is important to consult with the local authorities and insurance providers to determine which codes and standards apply to the specific installation. Compliance with all applicable codes and standards is essential to ensure the safety and reliability of the UPS system. To recap, when implementing overcurrent protection for a UPS system with an ATS, keep these points in mind. Firstly, consult NEC Section 705.15b3 for guidance on OCP device placement. Secondly, ensure the OCP device is appropriately sized for the load and coordinated with other protective devices. Thirdly, verify the interrupting rating and voltage rating of the OCP device meet the system requirements. Fourthly, properly size and install the disconnecting means for the UPS. Fifthly, engage a qualified electrical contractor for installation and compliance with applicable codes. Sixthly, perform regular maintenance and testing of the UPS system and OCP devices. By adhering to these guidelines, the installation can be executed safely and reliably.